All right, so today we're going to continue our lesson on functions versus non-functions. And our real focus today, you already know the definition of a function versus non-function, and that is that your x value has only one y value, meaning that our line can never backtrack, meaning that when we plug it into an equation, we only have that one response. Now today we're going to focus more on the visual side. So this is going to be more like our warm-up. So here's a table. Okay, and on this table we've got our x's and our y's. So notice that if x is 1, y is 2, x is 2, y is 4, yada, yada, yada. You can all read that table just fine, I believe. But if we look at what's not a function, can anybody tell me why that table is not a function? Evan?
Because x repeats.
Because right here, it's telling me that if x is 1, y is 2, and if x is 1, y is 5. Now this is kind of silly, but this is just how I interpret it. It's kind of like that 1 is cheating on the 2 with the 5, right? It can't be faithful. In order for a relationship to be functional, the x has to be loyal. And if that x starts stepping out and finding a different number, it's chaos. Okay? Cheesy, I know, but I think you guys understand where I'm going with that, right? The y is asking, why? Why did you do this to me? Yeah? No? No? Too far? Too far? Okay, all right.
We don't want to learn about real life yet.
Do what?
We don't want to learn about real life yet.
I just want you guys to be prepared. To have a functional relationship, you have to be faithful, okay? Are we okay with that table? All right, somebody explain to me. Why is the first table a function? Why is the second one not a function? Carter, go.
Because it never repeats the x on the function, but it does repeat the x on the non-function.
But right here I have negative 3 and 3. Aren't those the same number?
No.
Good. Negative 3 and positive 3 are very different, right? If Luke scores negative 3 points in a game, Luke had a really, really, really bad game. If Luke scores 3 points in a game, hey, we're happy. That helped us win. Does that make sense? Okay? Over here, though, again, this negative 2, it can't make up its mind. Does it want to be with 6 or does it want to be with 20? Doesn't know. And therefore, they're both unhappy, so it can't functionally work. All right, here we go. What do we call these? Ordered pairs, very good. And what is the significance of an ordered pair? What do we use ordered pairs for? Charging. Yeah, we use it for graphs, right? Luke, can you tell me, is this the x value or the y value? I'm sorry, is this the x value or the y value? This is x, right? And therefore, this is the y. Let me ask you this question, Stone. Does x go horizontal or vertical?
Horizontal.
Horizontal, right? Because again, you have to, how did I say this? I'm gonna teach this. You have to go into the elevator before you can go up or down, right? You can't just stand in the hallway and expect to go up and down. That's magic, and we can't do magic yet. One day, maybe, but not yet. Okay? X and Y. Notice 4, 5, 6, 7, 8. It never repeats. 4, 4, 5, 5. Both of those are wrong. See the difference? Okay. These are what we call bubble maps. And these are not really like mathematically important. I don't know. They're kind of unique. They're used really for this model and this model only. All it is just another way to represent how to show the numbers. And let me explain to you what it means. The arrows are going to the number that they connect with, the ordered pair that they create. Now, when I look at this though, I said that x can never repeat. But is it okay if the 4 and the 5 both share the 8? That's okay, right? Like, I don't really have a good witty relationship joke here because I just don't. But I don't care if the y value repeats. It's the x value that I have a problem with. We're good there. And if we were to graph that, just to give you a brief idea, if I were to graph it, 4, 8 is going to be here, and 5, 8 is going to be here. So I draw a line. Notice it's still sticking true to the policy of the x value never repeating. Let me see who we got joining us real quick. Any guesses? Anybody want to guess what it's going to be?
Colin. Colin.
Colin's good guess. It's actually Ben.
Oh, it's been.
Welcome, Ben. Sorry today, bud. The internet is down on the main computer, so my laptop, the cord that I have only reaches this far. So all you're going to be able to hear is my verbal. We're on the PowerPoint right now. I am recording it, and I'll upload it as soon as I'm done, though, okay? Cool. Thanks, sir. All right, so is everybody cool with the bubble maps real quick? Why one's a function, why one's not a function? Okay, good. And again, you can see by this 5 right here, notice that it's going to both numbers, so that's the reason it's stepping out. Okay, again, another bubble map. Now, I like showing you this example because this one gets a little bit more creative. Notice there's a lot more lines going all over the place. But again, -3 only has 1, -2 has 1, -1 has 1, 0 has 1, and 1 has 1. So we're good there. Over here, though, the 1's the bad guy. The 1 is not doing what it's supposed to be doing. Okay? I think these next ones are graphs.
I never knew when to be that high.
All right, so when we have graphs, we do what's called the vertical line test. Can anybody show me with their arms what vertical looks like? Yeah, vertical, straight up and down. The best way that I was taught this is horizontal is like the horizon or the sun. As it rises up, I'm sure that's how you heard it as well, right? No? Maybe. Vertical is straight up and down. Vertical is straight up and down. So just kind of keep that in mind. So the vertical line test, you can take your finger, you can take a pencil, a marker, whatever you have, and if you run it across the line, how many times do I cross the line? Which means that it's a function because, again, every x value on my x-axis only has one value there. Are we okay there? But if I do it on this next one, how many times am I crossing the line? 2. And therefore, if I'm crossing it twice, therefore, I'm completely negating the definition of what a function is. Good? I could never make it do that again if I tried. I bet I could. So we're good there? Function versus non-function. I think I got 1 or 2 more examples to show you. Okay, here. This is not a straight line. It's not a straight line. But if I do my vertical line test, though, it doesn't matter. It's still continuing to move the entire time. Still a function. Over here, now, one issue that my students had last year is when I was showing them this, they're like, well, you don't actually go through it at all. Okay, that's fair. But we also understand that like this is just an example and implying that the line goes all the way through, right? Then it does show that it is repeating by hitting it at this point and this point. Does that make sense? All right, cool. All right, and the last one. One of these is a little bit hard to tell, so we'll make sure we analyze it. But again, this one obviously is going all the way up, all the way through. Now here's the final piece you need to understand about function versus non-function. It doesn't matter if at other points it only goes through once. So like right here, if I were to do the vertical line test, well that looks like a function, right? I'm only going through the line one time. But it's at any point in the data, so like here, when I go through twice, is where it messes up. If it changes at any point, that's when it declares it's not a function. We good there? All right, that's the lesson today, ladies and gentlemen, is can you understand when we have a function versus when we do not have a function? Do we understand that? All right, go to the next page. Let me talk about the quiz with you real quick. So this is a 10-question quiz. Don't start it yet. I'm not because I don't want you to get ahead. I just want you to see it with me so you don't have any questions. I have put images on here. And all you are doing is telling me this is a function, true or false. Do you understand? That is literally all you're doing. So while you're taking this 10-question quiz, I'm going to move around. When you finish the 10-question quiz, you have a reflection. Okay? If everybody finishes, then I'll add a little bit more to the end of the period. But we've got about 15 minutes left of class. So I want you to do the quiz, check on grades, check on corrections. You need to send me anything so that you can be ready for tutorials tomorrow. Once I've got grades and everybody finishes, then we'll jump back into a little bit more lesson, okay? All right, cool. Let's stop the video.